Hello, today we are going to talk about Radian Measure. In Radian Measure, we are going to find out what it means, what is its definition, and where it is used. Objectives. We are going to learn about the definition of a radian measure. We are going to use radian to calculate the length. We are going to use radian measure to calculate the area of the sector, and we are going to use GDC to convert radian to degrees. Let's observe keenly and find out what is the meaning of a radian measure. Look at the length of the arc, which is in red, and look at the radius of the circle. We are forming a sector of a circle. So I want you to observe the behavior of the arc length and the radius of the circle at different points. At this point, you can see 4.5, 4.5, 4.5. This time, you can see 3.6 radius, 3.6, and the arc length is 3.6. Let's change again, 2.65, 2.65, 2.64. A small error there is okay. Then we can have 7.16 as our radius, 7.16, 7.16, 7.16. I hope at this time you are asking yourself what is happening. What is this kind of a pattern that we forming when we are trying to adjust the radius of the circle and the arc length? Aren't we finding something? And look at the angle at the center there. The angle at the center does not change, but the arc length and radius are equal. Are we getting something from this? Now, look at our summary here. The radius, that's the radius, and the arc length, the distance is the same. Look at the three of them. The distance is the same, irrespective of the radius that I'm going to use. Then, what are we learning from that illustration? We are trying to get the following from there. Taking this particular circle with radius r and this radius r, we are seeing that the arc length is r. And that is where the definition of a radian comes from. So a radian then is a situation where the radius and the arc length have the same distance. As simple as that. It is a very accurate and important measure that we have in the world at this particular time. And it is acceptable worldwide. So look at these then. When the arc length and the radius are the same, then we have 1 radian measure. So that particular measurement you see there, theta, it is 1 radian already. And then we are asking ourselves, if that is 1 radian, then what about if we are talking about the whole circle? If we talk about the whole circle, then we know that the whole circle is equals to what? The length of the whole circle, totals to what? Then we find that the whole circle totals to 2 pi r. So then we are asking, if 1 radian measure takes the length r and the total circle takes the length 2 pi r, then the question is, how many radians do we have in our circle? One complete circle takes how many radians? And that is now how we are coming to use or substitute radian to degrees. Then we are going to get what? We are going to get 2 pi radians. So a complete circle has 2 pi radian. As simple as that, 2 pi radian, which is written as 2 pi raised to c. So if you see anything raised to c, that means radian measure. So therefore, as we master that, let us look at the summary of the above explanation that we have gone through. So we know that the area of a sector, even from the previous experience, we obtained it by theta over 360 times 2 pi r, 2 pi r squared, sorry. But now we are going to have a small change. That is when we had the degree. Now, what about now? At this particular time, we are getting that in radian, things are going to change slightly. We are going to have theta over 2 pi now, because we are talking about radian, and theta is in radian form. Then times pi r squared. Then theta over 2 pi means the fraction of a circle. That is the fraction that we are getting. Then in this case, we can still simplify that formula further to be as follows. So you can see that the pi and the pi are common, which means they can divide one another. So what remains is a half theta r squared. This simply becomes the formula for the area of a sector using radian. Now let's come to the circumference. Previously, we knew that for us to get the circumference of a circle or a sector, a sector, we used 3 theta over 360, then times 2 pi r. Then, now that we have the radian, what will be the difference? At that particular point, it was in degrees. Now, let's go to the radian. When we have in radian, we have seen that in radian form, we have seen that it is theta over 2 pi, as usual, which is now in radian, times 2 pi r. So it tells you something. Pi is common, and then 2 is common also. Then what's the formula that is remaining here? We are remaining with theta times r. So when you're using radian, for you to get the arc length, you just multiply theta times r, where theta is in radian form. Remember that. So let's have, we have now the two formulas that you're going to add to the formulas that you know. So one of the formulas we have discovered that for us to get the area in radian, and we are talking about a sector of a circle, don't forget that, it is a half theta r squared. Also, remember that we are also talking about, that is, we said we are talking about the sector. In second, we are talking about also the circumference, which is the arc length of a circle, which we are also now getting, it is theta times r. You see, the formula is simple and clear. Okay, so in this case then, we can have an example that will help us go through this particular situation. So the first example here is that you're told to find the area of the sector with the angle subtended by the arc is, which is 2.5 radian. So we know that the area is a half times theta r squared. So it's a half times 2.5 times 10 squared, which is 250 centimeters squared. As simple as that. That is how to get the area of a sector given the angle in radian form. Now, in the second example that we have, you can see that you've been given the angle at the center there is 0.8 radian, and you've been given the arc length, and then you are supposed to find the area of the sector. So how do we find this? We know that for us to find the sector AB, it is 0.8 times r, which is theta times r, which gives you 5. So r is 7.59. So when you substitute, you get 24 point as your answer down there. Now, how do we use then the calculator for us to do the conversion? It's very simple. You go to the mode and you change the radian to degree. We want to change the radian there to degree. So change it there to degree. So enter. So clear it after you've entered. Then let us change something that we know. Like we have realized that 2 pi is equals to the total circle, which is 360. So let's see how it can work. It can work out. So 2 pi. So you want to change 2 pi, but you have to activate. Remember, activate the radian, which is go up to the third one there. Activate the radian. Yes, activate the radian there. Okay, now it is activated, 2 pi radian. Then enter. Then it gives you 360 degrees. That one is now in degrees. Okay. If you also want to change radian to degrees, it is just the same thing. You activate now the radian. You go down, activate the radian. Okay, activate the radian. Now let us change also 360 to radian measure. Now 360, that the one that we have just dealt with, 360 degrees. So you make sure that after you've done that, activate the angle. Activate the angle. So second, go to the angle there. So activate the angle. So that is degrees. That is okay. Enter. So it's now in degrees. Then now you can do it in radian form. 6.2831. So that one, 2 pi, which represents 2 pi. So we can have an explanation of the 6.28 here. So when we have seen that 2 pi radian is equals to 360 degrees. So we can then say that 360 degrees is equals to 6.28 something that we have found there, 31 radian. So we know that 6.238 is equals to 2 pi, which is obtained from the definition up there, okay, which means is 2 times 3.142, okay, which gives you 6.28, 3 and something, 3 there, or 84, because it is an approximation at that particular point. So students, that is how you can work it out. Can you find more and do more questions which will give you more experience in this particular area? Thank you and be blessed.